look up here at the screen. Learning Target 1. Actually, we're going to do Learning Target 1 and Learning Target 3 today. So we're going to identify whether a given relation is a function, and then we're going to evaluate functions that are given to us in function notation. Now, to be able to do the first learning target, we have to know what a relation is and we have to know what a function is. Here are my definitions. A relation is a set of ordered pairs. And they can just be written as a list. You know, it could just be a list of ordered pairs, and I'll show you some of those here in just a few minutes. Or they can be written as an equation. Because remember when you first learned how to graph lines, remember how you graphed them? You took your equation, like y equals 2x plus 3, and you made up a value for x, and then you figured out what the y was that went with it, and you came up with a list of points. Because the equation, instead of listing all the ordered pairs, just describes how you can find all of the ordered pairs. And in my least favorite way, even though books love it, they can be written as inputs and outputs, where there'll just be a list, inputs, and then usually an arrow going to outputs. And they can also be given to you as a graph. We're familiar with graphing. All these things are relations. Now, you've heard the word relation before, but you probably barely ever worked with them. Because the kind of relation that we really like in math, and it's not the only one that we like, but the one that we like the most is a function. And all a function is a relation in which each x coordinate is different. It's a set of ordered pairs where every x coordinate is different from every other x coordinate. Okay? No two x coordinates are the same. That's the difference, and that's the only difference between a function and a relation. So, a function is a special type of relation. It's a special type of a list of ordered pairs. It's a list of ordered pairs where no two x coordinates are the same. That's all a function is. Just like relations, functions can be written out. You can write out a bunch of ordered pairs. Or you can write out an equation. Or you can write out inputs and outputs. Or you can draw a graph. All of those things work because a function is a type of relation. So, let's take a look at this. I'm not sure you've ever done it quite like this before. But I was supposed to cut these out as cards and pass them out, and let's take about a week and a half to figure out whether or not we can tell what a function is. But I figured we can do it in about 2 minutes instead. So, are these things functions or not? So when you look at A, we're given a graph here. Is this a graph of a function, or is it simply a graph of a relation? All we have to decide is, are all of the x coordinates different? If the answer is yes, it's a function. If any two x coordinates are the same, then the answer is no, it's not a function. So for A, are all the x coordinates different? Yes. It's a function. What about B? Instead of a nice continuous graph, they just give us a list of points. Is B a function? No, because those 2 points right there have the same x coordinate. So that one's not. What about C? Yep. And D? No, there's a bunch of x coordinates that have the same. Remember something called the vertical line test? Did y'all ever have that? Because in a vertical line, let me draw a vertical line here. Make it a color that will stand out. In a vertical line, aren't all of the x coordinates on that vertical line the same x coordinate? So if a vertical line hits a graph twice, then both of those points where it hits have the same x coordinate. So there's a whole mess of points with the same x coordinate. In fact, right there, there'd be, what, 4 points with the same x coordinate. All it takes, like up here, is one set of ordered pairs where the x-coordinates are the same for it to not be a function. So number D, letter D is no. All right, now here we have, it's a table, but it's really a list of ordered pairs. 0, 1 is one of your ordered pairs. That's your next one. That's your next one. That's your next one. Are all of the x-coordinates different? Yes. This one's a function. What about F? Is F a function? No. G? Yep. H? No. Any questions? Okay. Now, got this from a book, so you can see a book definition. A function is a relationship between input and output. In a function, there's exactly one output for each input. And then here we get into some words that we're not going to concentrate on today, but we are going to concentrate on. Domain and range. The domain is just the set of x-coordinates. The range is the set of y-coordinates. The domain is the set of inputs. The range is the set of outputs. So, going by my definition of function, if every element in the domain is different, it's a function, isn't it? Because these are the x-coordinates. The domain are the x-coordinates, the inputs. The range are the y-coordinates, the outputs. So, as long as each input, each x is different, it's still a function. So far, so good? Okay. And then some book-type examples. So, again, just tell whether or not the relation is a function. So if you look at A, every element in the domain is different from every other element in the domain. So, yes, that one's a function. Now, B, for some reason, they wrote it as a table, and I really don't like the way they wrote this. I don't mind going horizontal, but if you do, you need to put the x's on top and the y's on the bottom. They reversed it. These are the y's, these are x's. Domain is x's. You should never put that on the bottom. I don't know why they did that, but they did. Are all the members of the domain different? No. These are the same. So this one's not a function. And then the next one, no, because that x-coordinate and that x-coordinate are the same, or that one and that. All it takes is one example to make it not a function. No. You're starting to get the idea it's going to be important that no matter how the function is written for you or how the relation is written for you, you've got to be able to tell if it's a function or not. So there's a lot of different ways, and we've got to be able to tell. All right, so here's the vertical line test. If a vertical line hits twice or more, it's not the graph of a function. So for this first example, is that vertical line ever going to hit 2 times? No, so that one's a function. What about the middle one? Yeah, it hits twice, so this one's not a function. What about this one? Here's the question right here, right? Does that hit twice? No, because look, see the open circle on the top? That's the x equals 0 right here isn't actually on the graph, is it? It is down here because it's closed in, but it's not at the top because it's an open circle. So right there is the only place where it looks like it might, the vertical line might hit 2 times, but it doesn't, because you got to remember open circle versus closed circle. So, function, not a function. Oops, let's stay consistent. Function. All right? So, more and more ways. You can write this as a table. I would rather say a list of ordered pairs, but table, XY table, mapping, that means giving you enough information that you can draw a graph, giving you the domain, those are the x-coordinates, the range, those are the y-coordinates. An equation or a graph. All right, still doing the same thing. Number 2, function, not a function. Function. Number 3, function, not a function. Function. Every x-coordinate's different. Function. What about number 5? Not a function, because, look, it's a vertical line itself. All of the x-coordinates are the same, so that's a big no on that one. Number 8, not a function, because the x-coordinates are the same there. Number 9, function. You think you've seen enough examples? I think so. All right, so let's try it this way. Okay, going back to this. At the top here, I, function or no? Function, input. Remember, input and domain and x-coordinate. And let me throw another one at you. Independent variable. All mean the same thing. We'll get to independent variable quite a bit here in the next few days, but I just wanted to throw that out there. So I is a function. What about J? Why not? Oh, I've been looking at these wrong. They are telling you to use 42 twice, aren't they? Ooh, I may have said some of these wrong. Has that come up before? Oh, yeah, it came up here. This one should have been not a function because -1 was used twice. Ooh, good catch, Hannah. I didn't even see the multiple arrows. So, y'all with me? You see the mistake I was making? Okay, so that one's not a function because 42 goes with the 120 and with the 200s, used twice. What about K? Function. L. Yeah, not even close, right? Now, with equations, you kind of have to know what the graph's going to look like to make this easy. If you remember, remember this, y equals mx plus b. Those are linear functions, okay? And as long as it's not a vertical line, and it's not, because a vertical line would look like x equals a number. As long as it's not a vertical line, lines are functions. So m is a function, and so is o, okay? But now, when we get to things like n and p, if I used, let's look at p first. Look at p down here, okay? If I used, let's say, 5 for x, or I used -5 for x, when I solve this thing for y, I'm going to get the same y. Because watch, when I square the 5, I get 25. So I get y squared equals 0, which means y equals 0. And when I square the -5, I get 25, which means y squared equals 0 and y equals 0. So look, I would have the ordered pair 5, 0, and I would have the ordered pair, wait a minute, I'm looking at it backwards. Darn it. It's the y I want to put the 5 and the -5 in for. Yeah, because if I put the 5 in for y, let's see if I can fix this. That'd be x squared plus 25, x squared equals 0, x equals 0. And if I do it here, that'll be x squared plus -5 squared, x squared, 25, so x squared equals 0, so x equals 0. So I get 0, -5, and 0, 5, not a function. Okay? And for anytime you can put two different y's and end up with the same x, not a function. Like this one right above here. See, I can do the same kind of thing. If I put in a negative 5, the left side becomes 25. If I put in a positive 5, the left side becomes 25. So when I solve it, I'll get one x that has two different y's going with it. So this one would be not a function as well. Okay? Y'all following me? I think we've seen enough of these. All right, learning target number 3. Evaluate functions that are given to you in function notation. One of the learning targets from Unit 1, one of the very first days of school, was to evaluate expressions given the value of a variable. This is the same thing. Okay? Now, you got to understand function notation. When we write f of x, that's the way you read that, f of x. It is not f times x. F of x. It's telling you two things. It's telling you that the name of the function is f and that the variable of the function is x. F of x means function of x. Okay? So, they're telling you it's a function. You don't have to guess. They're telling you it's a function. So, f of x equals 3x minus 8. And look, that's equivalent to y equals 3x minus 8. In other words, y and f of x are the same thing. Y and f of x are the same thing. Always, 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 always. Okay? So, when they give us a function, and let me cover up that top part. So when they give us a function like this, f of x equals negative 4x plus 7, that's a linear function, because if it was written as y equals negative 4x plus 7, that's in slope-intercept form for a line, isn't it? So you graph that, that's a line, so it's a linear function. Now, what f of 2 means is simply replace the x with a 2. Notice how whatever's in the parentheses, those are the same. Those are your x's. Okay? So if f of x equals negative 4x plus 7, f of 2 equals negative 4 times 2 plus 7. You follow me? Substitute whatever's in the parentheses here for your x. Now, isn't this easier than the evaluation problems we started the year with? It's the same idea, but hopefully they're a little bit easier. So, negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. So what we found is that f of 2 equals negative 1. B says to find f of negative 3 plus 1. So first, let's write down what f of negative 3 is going to equal. Remember what f of x is. It hasn't changed for the whole problem. So f of negative 3 will be negative 4 times negative 3 plus 7, right? And then what am I supposed to put after that? Plus 1. Everybody with me? So f of negative 3 is this, and then the plus 1 is this. All right, so what do we get? Well, negative 4 times negative 3 is positive 12, plus 7, plus 1, so we should get about 20, shouldn't we? Any questions? All right, don't let the notation, remember what notation means? The way you write things down. Don't let the notation mess with you, because I've done this before, and then all of a sudden on a quiz, I'll have a student call me over, and they'll say, what am I supposed to multiply that 3 times? That's not what this notation means. Parentheses can be confusing because they're used for so many different things. They're used as grouping symbols. They're used to mean multiply. Now they're used in function notation. So how do you know which is which? From the context. From the context of the problem. This is not a multiplication problem. This is an evaluation problem. All right, a function with a variable term that has an exponent other than 1 forms a nonlinear function, and the graph is not a line. And you saw some of these in Algebra 2, and we're going to get to them as well. But, you know, stuff like this, that'd be a parabola. And then you can even get into other polynomial functions. That one would look kind of like that. Okay, you don't have to know what they're going to look like. But anyway, they're not linear. But it's okay to have a square on the x, but they're not going to be linear. Any questions? Now, we spent a lot more time on the identifying than we did the evaluating, and that was by design because we've done the evaluating before. So are we okay with the function notation telling you how to evaluate? All right. So I'm going to give you a worksheet and let you get to work.